Assalamualaikum, my name is Rusmawani binti Ramli. In this video, we will discuss about a spectroscopic technique of our choice, which is inductively coupled plasma optical emission spectrometry (ICP-OES), that is used to analyze toxic heavy metals in fish. Firstly, let's see why is it important to analyze toxic heavy metals in fish. In recent decades, due to the increase in industrialization, urbanization, and agricultural wastewater, the accumulation of heavy and toxic metals in aquatic species and ecosystems has become a significant environmental concern that has a negative impact on the health of humans, animals, and plants. Fish and seafood are the main aquatic species that give unsaturated fatty acid and protein to the human diet, and their consumption has grown over time because of their many beneficial nutritional and medicinal properties. However, fish frequently serve as the one of the primary exposure sources, gradually accumulating metals to potentially harmful amounts that beyond the safe limits set by national and international regulations. Thus, by identifying the harmful heavy metals present in fish, we can protect consumers from harmful exposure and allowing for specific measures to protect aquatic ecosystems, address the causes of water pollution, and promote sustainability initiatives.
My name is Marina Huda binti Azhar. The technique used in this analysis is inductively coupled plasma optical emission spectrometry. Why ICP-OES is used over atomic absorption spectroscopy? Firstly, in ICP-OES, it can simultaneously analyze multiple elements, while AAS only can detect single element at a time. Since we want to determine the amount of various heavy metal in the fish, analysis using ICP-OES is more favorable. Secondly, it has lower detection limit than AAS, which it can detect and measure very small amount of an element in a sample. Thirdly, it also provides a wide dynamic range, which refers to the instrument's ability to accurately measure elements from very low trace levels to very high measure levels within the same range. Lastly, it also provides a fast analysis time since plasma provides high temperature, thus the atomization becomes faster.
In ICP-OES, atoms of the target analyte will interact with plasma, causing them to emit different wavelengths of light. The table shows the result from ICP-OES instrument, which is the value of the wavelength that is emitted by the metal atoms of the target elements. The difference in wavelength emitted by each element is due to the difference energy they release to go back to ground state from excited state. For quantitative analysis, the article uses ICP Expert 2 version 1.1 software to generate calibration curve for each metal after running the calibration levels. Generated calibration curve were accepted and passed for the analysis of metal concentration, metal detection limits, and recovery studies when R-square values for each metal were around 0.9994 plus minus 0.0004. The calibration levels were rerun until expected standard curve and R-square values were attained. Next, we move on to qualitative analysis. Levels of metals also depicted in this bar chart. All fish contain aluminium, arsenic, barium, cadmium, chromium, lead, stannum, and strontium at different concentration above metal detection limit, while antimony was not detected only in bluegill and crappie. Aluminium and strontium were found at the highest concentration in 60% of fish species. Cadmium was detected at the lowest concentration in most fish species, with the exception of catfish, where the level was approximately 300 times higher. The average metal concentration in each fish is also calculated and compared. Average metal concentration in descending trend is starting with catfish with the highest amount, followed by largemouth bass, crappie, tilapia, and bluegill, the lowest. The recommended permissible limits for arsenic, cadmium, chromium, lead, antimony, and stannum in fish established are shown in the table. Accordingly, the arsenic, chromium, antimony, and strontium levels in all analyzed samples were within these limits, implying no possible adverse health effects. Cadmium levels in all analyzed samples were within these established limits, apart from catfish, which showed higher concentration than the limits. Lead levels were elevated only in largemouth bass and catfish, where they were observed to be higher than the recommended limits. Therefore, largemouth bass and catfish contain high value of cadmium and lead than the tolerable limit, which can be concluded as unsafe to be consumed. So far, there is no upper limit set for barium, aluminium, and strontium in fish by advisory organization. However, based on their tolerable daily intake limit values determined by FAO WHO, their permissible limits in fish were estimated to be approximately 7, 42, and 45 mg per kilogram by using an average body weight of 70 kg for an adult and daily fish consumption of 200 grams of fish per day. Considering these estimated limits, we can conclude that their values in analyzed fish samples are below the tolerable daily intake and are not sufficient to pose a health concern. There are some comments that can be made about the data. Firstly is about MDL. MDL is method detection limit, which is defined as the lowest concentration of an analyte that can be reliably detected in a sample matrix. The method detection limits values are very low, which between 0.001 to 0.099 mg per kilogram. It indicates that the ICP-OES instrument can identify analytes at extremely low concentrations, improving the accuracy and precision of the results. It is more reliable to use the data as a guide when determining how much and what type of fish are safe to be consumed each day to protect ourselves from those metals. Then the concentrations of all metals in fish samples were observed to vary, which might be due to some reasons, which is different ecological needs, metabolism, habitat type, and feeding habits of the fish.
The limitation of this analysis is the presence of matrix interference. Fish sample contains complex matrix such as protein, lipid, salts, and organic materials that can interfere with the detection of metals. Matrix can impact the recovery and extraction of metals. This means the metals might not fully extract from the fish sample, which can affect the results. It also affects the signal by amplifying or diminishing it. Another problem is the introduction of monoids, which make it harder to distinguish the metal signals from the background noise. This can lead to inaccurate readings. Based on the influence of plasma condition and high temperature, the matrix can affect the excitation and emission line of the individual metals. This means it changes how metals behave in the plasma, which affect detection. There can also be variation in the intensity of the emitted light, which led to inaccuracy in metal concentration measurement. To improve the limitation, a pre-concentration and clean-up technique using dispersive microsonic phase extraction need to be done. Pectin stemless magnetic graphene oxide was applied for extraction of cadmium and lead in dispersive micro-SPE. Graphene oxide has hydrophilic functional group such as hydroxyl, carboxyl, and epoxy group. Those functional groups have lone pair that can effectively bind a metal ion, but graphene oxide has no biocompatibility. The biocompatibility is increased using pectin. Pectin contains hydroxyl and carboxyl group that allow absorption of metal ions into its surface. Then, the extracted sample were injected into ICP-OES. The analytical method using ICP-OES is sensitive because MDS value for all target metals range between 0.001 and 0.099 mg per kilogram indicate that ICP-OES can detect a very small amount of analytes. Next, the average relative standard deviation of concentration of target metals range from 1.32% to 8.05%. The RST value is below 10% indicate that the precision of the result is good. To determine the accuracy of the found concentration is verified further using certified material and IST SRM 9046. Student t-test was used for comparison between certified values and found concentration, shows good agreement between certified values and measured one.